Welcome back students. In this part, I'll be telling you about the boron family, which is the first P group, we have. So that comes under the 13th group. In this part, I'll be telling you about the properties which boron shows, the oxidation number which boron shows, the valency in which it may occur, also which are all the whole elements present in that group. They all properties, similarities we will learn in this group. So here we go with the presentation which I made exclusively for you guys. Check it out. Hi students, now our next part is boron family. So it is a first group of the P block element. It is the first group of the P block elements. Let's see. So boron family. Now group 13 elements. Firstly, they are boron, aluminium, gallium, indium and thallium. And the boron is only that non-metal in this group. All the others are what? All the others are your metals. And non-metallic character of boron, it is due to what? Its small size and high ionization energy. It is very small in size, due to which it is non-metal. And the general valence shell electronic configuration for this would be what? NS2 and P1, because it has, as I said, 13 group, right? So the last electron will enter the P group, and that is only one electron. So NS2 and P1. And these are some of the general trends, guys. You can see the configuration of boron, the configuration of aluminium, the configuration of gallium, the configuration of indium, the configuration of thallium. It will be like this. Okay. They all are one. They all will be one. It's wrong written here. They all are P1. And the common oxidation state for this will be +3, +3, +3, +3 and +3 and +1. So these all shows what? Variable oxidation state. But here, as this is the first group, okay, so only this is showing me variable, others are kind of same, +3. Means 2 in the S1 and 1 in the P1. So that will add my 2 + 1, right? So that's why +3. And here in thallium, what is happening? S is very close to the nucleus, okay, but P is at the outside. So that's why it can show +1 also. That is the point here. Here is the atomic radius trend. Obviously, if I move down the group, it will increase. But here is an exception here. Here, this is an exception here. Then, the first ionization enthalpy. So, obviously, the first ionization enthalpy, the larger the size, the smaller it will be. The smaller it will be. So, it will go like this. Electronegativity, again, the smaller the more size, the more it should have the electronegativity. Talking about the density, so it always increases down the group. You know that your mass always increases down the group, right? So that's why your density will increase. But aluminium is the exception here, okay, which shows low density. Melting and boiling point, if I go for the trend of melting and boiling point, so from my boron to gallium, it will decrease, and then gallium to thallium, it will increase. So gallium has the lowest melting point. In the whole group. And that's why it is liquid. That's why it is also liquid at room temperature, gallium. Talking about the atomic radii and ionic radii. So obviously from boron to thallium, the size will increase due to addition of the new electron shell, right, on the group. But GA is smaller than aluminium. So that is also an exception. Next, ionization energy trend. So obviously, if I move down the group, what will happen? A new shell is getting added and the last electron. For me, it is very easy to remove that last electron, right? So it will decrease down the group. So that's why ionization decreases down the group. Again, the case of gallium here is an exception case, okay, which has been earlier also. It has higher ionization energy than aluminium due to small size as compared to aluminium. So if size is small, that means what? My effective nuclear charge, that would be more. That would be more. So that's why ionization energy. In gallium case, this is an exception. If I talk about the metallic character, so obviously it will increase down the group. It will increase down the group. Next is oxidation state and reducing property. So this we have already seen that they shows +1 or +3, right? So boron group, they have 3 valence electron, okay, in the 2 in S subshell and one will be where? One will be in the P subshell. So, but other than boron, everyone, most of the one, they will exhibit +1 oxidation state, and down the group +1 oxidation state will become more stable, okay, it will become more stable. And reducing property, down the group reducing is like this, it will decrease, okay. Aluminium is more than gallium, than indium, than thallium. In this way, I can have my reducing property. Then chemical property trends. First is hydride formation. So if I talk about 13 group elements, they directly do not react with hydrogen, okay, but indirectly they react. Indirectly how? By giving them such conditions, okay, of say high temperature or concentrated solution, right, they form hydrides. And your boron hydrides, they are also known as what? Boranes, and they are of 2 types, I'll tell you. What are those 2 types? They are either in the form of BnHn+4 or BnHn+6. So this type is known as your nidoboranes, and this type is known as your arachnoboranes. Okay, these are the 2 types. And the simplest boron is your diboron, B2S6. And remember guys, make a note here, this is very important, B2S6, because your JEE exams, for them, for the question paper makers, B2S6 diboron is always a favorite molecule. Whether they will ask it about the structure or some bonding and all, everything. So this is one of the important molecule, B2S6. Always remember. How it is prepared? I just take BF3 and I pass it over the lithium hydride at 450 Kelvin. Now see how much large temperature this is, 450 Kelvin. So it will give me B2H6 plus LiF. Now let's talk about oxides and hydroxides. So it forms oxides like M2O3 and MOH3. Again, oxides will depend whether they are acidic one or the basic one, okay. Is a case of amphoteric, right, which shows both acidic and basic, and let's check it out. So as we move down the group, the acidic character, okay, the acidic character and the hydroxide decreases, and the basic character increases due to the strength of the, you can say it becomes more metallic, right, so that's why basic strength will increase, and your MO strength, it will decrease, so my basicity is increasing gradually. So this is like this, your B2O3 is greater than Al2O3, then gallium, then indium, then thallium. Similar is the case with respect to hydroxide also, okay, similar is the case with respect to hydroxide. So the trend in acidity basic character, it increases oxides and hydroxides of aluminium, gallium, and also your aluminium and gallium, okay, it shows your amphoteric nature. You can see here I have AlOH whole thrice, okay, and I am reacting this with the acid, so this is giving me a salt here. Even your Al2O3, okay, it may behave like a base, it may behave like a acidic nature also sometimes. This is all about the boron family, guys. So students, in this part we saw all the elements which are present in a boron family. We also see the chemical and physical properties which they possess, like oxidation state, oxides and hydroxides, how do they behave, okay, the metallic character, how does that go if I move from top to bottom in a group. Also we get to know about hydrides, borohydrides, right, and now I will in the next part will telling you about the important compound which comes in this group only, that is aluminium. So how do we extract aluminium? Do you know how do we extract aluminium? For that, stay tuned with me for that.